Hope everyone can hear me. Awesome. Thank you all for making it today. Super excited to be here. This is a great spot. My name is Rahul. I do machine learning at Tote. Thanks, Evelyn, for having me, firstly, giving me this opportunity to present. Firstly, a little about me. My interest in recommender systems began while I was in grad school. I built out for my final thesis, I built out a recommender system. The accuracy was terrible, but I learned a bunch of stuff. I ended up working in gaming for a few years before I moved to my current startup. I work at Tote as a machine learning engineer for about 70% of the time, and about 30% of the time, I do data science stuff. A fun fact about me, when I moved to San Francisco, my closet was filled with black and gray free tech stuff. And then after I joined Tote, it's the most recent picture of my closet. I'm learning a thing or two about fashion. All right, so I wanted to sort of broadly define what the problem that we see in the industry. Women purchase about 62, on average, 62 garments every year. And only get to use about 20% of those items. So there's a bunch of stuff sitting in the closet that's unused. That sort of roughly translates to about $160 billion worth of inventory not being utilized. So we've sort of seen over the past few years how traditional retail is kind of losing the edge. I know I'm standing here in Westfield and making like a bold statement, but the data backs it up. We're seeing revenue from like online businesses kind of like overtaking all the revenue that's coming in from like traditional malls. And the trend's only going to get better. So Tote is actually positioned in, actually strategically positioned really well in this regard. So what is Tote? Tote is a women's fashion tech company. For a monthly subscription fee, you get access to a bunch of clothing and accessory items delivered to your doorstep. You could wear them, keep whatever you like, and send items back. When you send items back, you get a bunch of other items shipped back to you. So this is how a typical box looks. So just to give you a sense of the data that we deal at Tote, historically, we've sent over 6 million items to customers, and we get a bunch of ratings on those items. Over 40 million virtual closet ads, which roughly translates to a wish list. Customers essentially go onto the website. They put items in a wish list that they tell us that they want in the future. This is all really good data, really clean and well-structured data that we could use to make better recommendations and sort of personalize the experience. We also collect. We also capture about 30,000. We've captured about 30,000 high-resolution images on the products. I'll get to why that's actually important, because we're sort of seeing this trend in the industry where deep learning is like taking off. So if we were to take a step back and kind of answer the question on why we need to personalize, Netflix has spent a bunch of time and effort into researching recommender systems. This is a paper written in 2012, and I quote from the paper. We think the combined effect of personalization and recommendations saves us more than $1 billion a year. This was back in 2012. Netflix is way bigger now. They're saving so much more money just essentially doing personalization and recommendations. What they ended up doing in the research is defining an effective catalog size. So they compared this heuristic called effective catalog size to a global popularity metric. And they realized that having personalization and recommendations essentially saved them a bunch of money. So this is great. If you were to solve the personalization problem by actually building out or writing code and building out something, what would the first thing that will come to your mind? So you could do essentially have humans kind of like pick items for customers. That's great, but that actually wouldn't scale as you add more users. You could just send random items to customers, which would be good for a very small cohort of customers, but then you would not keep like the entire customer base happy. So what you end up doing is actually building a recommendation engine. So if you've spent time on the internet, chances are that you've been served content from like a recommendation engine. This is my top pick list on Netflix. It's basically sci-fi, cooking, and nature shows. Netflix really gets the kind of stuff that I like and the kind of stuff that I'm into. Another example is, this is my Spotify Discover Weekly. All the songs driven from a recommendation engine. They really understand me. I really like this feature because I keep going back every Monday morning and refreshing opening up my Spotify app so I can see this list. And we strive to be that for women's fashion. Essentially, this feature that we built out is driven by a recommendation engine. Every Monday, you open up the app, you get a fresh list of recommended items shown to you. We collect really clean, explicit feedback on products, on the features of those products, customers liking them, disliking them, and what they think about the product itself. So if you were to take that and sort of formalize the problem, if you have a set of users and items on your platform, on your service, the goal is to sort of recommend a bunch of items to those users based on an objective function. The two things to keep in mind are the objective function and also if a user has seen an item before or not. So if you think of an objective function, it varies from company to company. For a company like Netflix, the objective function is to make someone sort of view either a TV show or a movie for a brief period of time or a length of time. For Spotify, the objective function is to make them listen to a song to the end. And for us, there are a couple of ways we think about it. We think about the objective function as a rating on an item, or if they've added it to a closet, or if they purchased an item. The other thing to keep in mind is, depending on the space that you're in, it's important to sort of think about resurfacing items part of your recommendation engine. For something like fashion, we've come to realize that customers don't like seeing the same item being shown across the app. For something like music, you listen to the same song like several times a day, so it's totally fine showing you that song like across the app. So there's several types of recommender systems, and the two of the most popular ones are collaborative filtering and content-based. Content-based has been taking off recently with deep learning and GPUs and a bunch of clean data sets. Collaborative filtering kind of took off when Netflix did the open dataset challenge back in 2008. So how does collaborative filtering actually work? There are two friends, Eve and Alice, that meet maybe at a meetup like this. Eve tells Alice, hey, I like that blue top and floral dress. And Alice says, oh, wait, I like those two as well. Have you tried the Nike athleisure top and red plaid shirt? I've kind of simplified this example, but if you take this example and extend it to like thousands of users and thousands of items, you get a really nice way to sort of put the data into a matrix. Not as cool as this one, but something more boring that a machine learning model can sort of understand. Essentially, what you're doing is you're capturing a bunch of interactions between users and items. There's one problem, though, with this. If your platform has more users than items, what you end up is a very sparse data set. One of the ways to sort of tackle this is through a technique called matrix factorization. I wouldn't get too deep into it in this talk, but I'm happy to chat about this after. But essentially what you're doing is you're learning a bunch of features on the product, you're learning a bunch of features on users, and you're taking this sparse matrix and breaking it down into smaller matrices. This opens up a bunch of use cases where you can learn similarities between items, and you can learn similarities between users. An example is if I were to run matrix factorization and find my entry in the matrix, I can find all the similar users to me. Or I can find all the similar items to this vest. The way we use it is we think about it from several different angles. One of them being categories. We think about it from colors. We think about it from prints. And same thing for product as well. So this is really awesome because in the end, what comes out of the matrix is actually probabilities on how likely is Eve going to like those items? So that's great. Collaborative filtering is very popular. It works really well. But what if you actually don't have all those ratings that you've collected? One approach is to sort of use like a content-based recommender system. This is an image of a 30-second song sample by Daft Punk. What it essentially, I don't think you can see it too clearly, but what essentially Spotify has done is they've broken down the song into like pitch strength and loudness. And this allows them to sort of find similar songs based on like what the content of the item is. We use deep learning as well. What you see on the top is the item in question, and what you see at the bottom is a list of similar items. The way we sort of use this is to feed it through a neural network. And the neural network essentially spits out a bunch of product features that it thinks are important. And that way we can do a bunch of clustering on top of the features. Again, I don't want to get too deep into like the technicalities of this, but I'm happy to chat about it after the talk. This opens up a bunch of use cases in the app itself. So let's say you're out of stock of a certain item. What you can end up doing is approximating to all the visually similar items. What you need to do is sort of define how you're doing the similarity. One of the things, of course, is the visual part of it. You could actually go dig deep into like an item and look at several different attributes of the item. OK, so chances are if you've been working with recommendation systems, you've run into like a cold start issue. A cold start problem is basically when you have a user, but you haven't collected any information from the user, but you really need to you want to recommend some items to this user. There's several different ways to tackle this, and I also want to say that it's an open research problem, so it's definitely a hard problem, and a lot of companies are working on it. But there's several different ways you can actually tackle it. I'll talk about a couple of them today. One of the things is to push the user to sort of give you like more implicit feedback. One of the things we do is we push them to add stuff into their virtual closet. That sort of gives us a sense of what they like for the future, and then we can run our recommendations on top of that. For a different service, it could be an item that they click on, their browse history. The other thing that you could do is to ask more questions. Actually, this is what we end up doing in our onboarding to get a sense of what the customer is interested in from getting out of the service. We asked them to take a style quiz and asked them to tell us what styles they actually like at a very broad sense. This is really useful because we can kind of do like a clustering on top of all the information that they've given us and find all the nearest neighbors to their answers. This helps us find, this sort of gives you an approximation as opposed to going to like a random set of items that you recommend. OK. Several key learnings from like sort of building recommenders over the past few years. The first one being fashion is very, very subjective. Luckily, we don't get any of our users asking for meat on their items. So we're lucky in that regard. Fashion, like music, is actually very, very subjective and personal. So there's all the more need to sort of run like a personalization on top of all the data that you have. You really want to show the customer that you're learning about them and you're listening to them and looking at their feedback. The second key learning is the context in which you recommend items is very, very important. There is an explore versus exploit trade-off that you have to deal with. And it's very important to understand the kind of customer you're recommending to and the point at which you're making recommendations. An example for that is there are types of customers who like sticking to a particular category. They like dresses, and they like receiving only dresses. But there's also another kind of customers that want to sort of explore and discover more. So they want to receive like skirts that they want to wear for work. So it's really important to understand all these things and sort of understand who you're recommending to at what stage you're recommending items to. The third key learning is you need to have a North Star metric that sort of drives your recommendations. It's for us, we really care about getting customers to like items when they receive it. We're not a traditional e-commerce company, so we don't really care about people making like the purchases. It's a side effect of actually making good recommendations. It's not something that drives us. What we really care about is people liking items and actually getting better, our recommendations getting better over time. So it indirectly affects a bunch of business metrics like your lifetime value, your customer acquisition costs, and also your churn numbers. Equally important to actually the results of your recommendations, it's how you present them. I think that's very important as well. You need to be able to communicate why something is being recommended to a user. Actually having that message goes a long way, giving them the direct feedback on why they received a certain brand based on their past patterns. So just to kind of iterate on that. Okay, so with that, I'm going to move on to the second part of the talk, which is how we price items. Pricing is really important to us. I just want to give you some context on how this sort of business works. We have a warehouse in Stockton where thousands of items are shipped every day to customers. Tote is a rental service. We really care about price, and we also get the items back. We have a custom inventory management software, so that lets us optimize on a bunch of different metrics. Just to give you a sense of the inventory data we deal with, over 5 million items shipped historically. Over 70% of customers have actually made at least one purchase. There's 20 different inventory and fashion sort of features that we look at that actually influence the purchase. So why is pricing important, and how can we actually use machine learning to sort of determine pricing? A garment actually goes through several different wears, and it has a life cycle that we've sort of defined. So it's really important to utilize the life cycle of a garment and sort of set the price based on based on the wears that the garment has gone through. So here's some math on how to sort of define that. Historically, we've shipped out millions of items, and then customers have made a bunch of different purchases. So we have all these like clean data of all the labels are basically if a customer has made a purchase or not. So we have all this clean data that we can go and build a function on top of. So given a bunch of labels, we want to learn a function that predicts if a customer is going to make a purchase or not. So we want to build a classifier. So the technique that we use is stochastic gradient descent. It's a very popular technique. Essentially what you're doing is learning a bunch of weights that actually reduce the error rate. You can actually define this as a hill climbing problem. The way to think about it is you're stuck at the bottom of a hill. You can only see a few meters ahead of you, but you're trying to get to the top of the hill. One of the techniques that you use is to sort of make small steps in the direction to the top, and you take down how steep your ascent is. And you keep adjusting your steps based on how steep the ascent is. And in the end, you'll actually reach the top. So most machine learning sort of classifiers use a very popular technique, and this is out there. So all this is fine, but you have to keep in mind online accuracy is really important. You can make all these assumptions offline, but nothing beats putting your model in front of user and sort of getting feedback from them. Okay, so key learnings. In terms of pricing, I think consistency is really important. You need to show the same price across your service. You're opening up a PR disaster if you show sort of multiple different prices for the same product for the same customer. It's for Tote, which is a rental service. Because of the nature of the data, we sort of deal with the imbalanced data set. So it's really important to sort of treat that while you actually train your model. The other thing to keep in mind is, I think there's a lot of talk about this in general in the industry, is to sort of train these models that that do not have bias. What ends up happening is you sort of, because you collected all this data historically, you've trained this model to sort of favor a particular type of customer. An example for that is I go on Uniqlo and I make a bunch of purchases, and Uniqlo is trying to build this model for me to make me like purchase, and there's people sitting somewhere else who've only made one purchase. The model should not favor someone who's given them a bunch of money. So you have to make all these checks and balances that prevent that, keep that in mind. There's really great literature out there to sort of deal with things like this. The fourth thing to keep in mind is the pricing actually affects brand perception. Blue Bottle is my favorite coffee shop in San Francisco. So I honestly don't know why I put that there, but I think it's really important to have checks and balances on how low or how high you go with your pricing. Because that can have a very significant impact on the brands that you actually sell. Okay, I'm not sure how I'm doing with time, but these are some of the open problems that we face at Tote. Very interesting challenges. We're trying to form this fashion knowledge graph. We also want to better understand customer style personas. We want to build tools to let merchandising really predict fashion trends and make better purchases. We want to use external data sources like Pinterest and your sort of your fashion activity on the rest of the web to kind of make your personalizations better. In terms of pricing, we're thinking about doing relative pricing of items in a box. It's a math-heavy problem, and of course, we want to optimize the usable life cycle of an item. Essentially, trying to figure out at what point you want to discount an item and how much to price it at. And we're hiring. We're hiring data scientists, we're hiring data engineers, and we're hiring software engineers that love to work on personalization. That's our career page. Shyam, our VP of Engineering, is sitting right there, so feel free to come and chat with us if you're interested. With that, I'll open it up for Q&A.